Hey everybody, happy Thursday. Thanks for joining our SageMaker webinar today. We're going to be covering the linear learner built-in algorithm. My name is Sue Ewig, and I'm the AWS Global Partner Marketing Manager for AI and Machine Learning, and we are so glad to have you today. Let's talk quickly about who else is on the call today. Everybody attending this webinar today belongs to one of the 12 consulting partners who have achieved the AWS machine learning competency. So it's a big webinar. There's a lot of you, but it's a private webinar. So I want you to feel free to ask any and all questions that you have in the question window in the right navigation table. You can send those questions just to our presenters so we see them only, or you can make them visible to everybody, whatever you're comfortable with. So let's introduce our presenters from AWS for today. Chris Burns will be our main presenter. That's Chris with a C. He is based in Austin, Texas, and he's a partner solution architect focused on machine learning. Just so we don't confuse, we also have another Chris on the call as well. He is Chris Grenak with a K, and he'll be making sure that your questions get asked and answered. I think Chris is based in San Francisco today, but it could be Seattle. We're going to nickname him Waldo because we never know where he's going to turn up. In any case, Chris is the machine learning lead for the partner solution architects for AWS. So let's get started. Let's dig into this meaty topic on SageMaker's linear learner. Chris Burns, are you ready to get this started?
I am.
Awesome.
Thank you, Sue. Okay, so welcome to the SageMaker Deep Dive series. This is issue number 4, if I can say issue, I guess broadcast number 4, the Linear Learner edition. Now, today's webinar is going to be delivered 100% from this notebook here that you see on your screen. I wanted to try something new. I wanted to give you fewer downloads and the ability to review the material as it was presented rather than a PowerPoint and maybe a template notebook. Now, if this proves to be less efficient than a PowerPoint, I want to apologize in advance for making you all my guinea pigs. But hey, that's what it's all about, right? It's about machine learning. So I want to put this webinar into some perspective and set some expectations. The goal at AWS is to make machine learning available to everyone in the context of cloud computing at AWS, which hopefully is synonymous to you with scalability, elasticity, and highly available services. Excuse me. Now, that being said, I want to try to make this webinar informative for everyone, whether you're a data scientist, a developer, a machine learning practitioner, whether you work in DevOps, or whether you're a hippo. Hippo is industry's term of endearment for the highest paid person's opinion. So if any of those are on the call, welcome to you as well. Now, in the next hour, I plan to write a bit of code, talk a bit about data sets, and put it all together into what's going to be hopefully a useful demo for you. This one is interesting for several reasons. The linear learner is not deep learning. So again, I want to say thanks again for everybody that attended, because it's not the sexiest technology out there. But this quote, if you see there, I put out here this quote from Andrew Carnegie. This is one of the first things I learned when I shifted from development and architecture into machine learning about 2013. It was a regression. And the reason it attracted me was because I could actually understand the math. I coming from a mechanical engineering background, I should have been stronger in calculus than I was, but really trigonometry and linear algebra were my strong suits. But I love this quote from Andrew Carnegie. So if this is new to you, if you're new to machine learning, it's baby steps, it's asking questions, it's asking for help from us PSAs. We're here to help you out, especially this group of participants that are our competency partners. And then this other one from George Box, it's a great one. It should be probably pinned to everybody's cubicle. It's all models are wrong, but some are useful. Now, back to the linear learner, the built-in linear learner. This is a distributed stochastic gradient descent is what this is. It's not deep learning. And with the linear learner, you have 3 options. You could do binary classification, which is going to return you a result between 0 and 1. So as such, the binary classifier expects the label to be 0 or 1 in our data set, and the label is the target label. We'll get into that in just a little bit. The binary classifier is a great tool for asking yes and no questions. Will this be the year the Cleveland Browns actually win a game? I don't know. That's just a joke. I'm from Cleveland. I'm a diehard Browns fan, so I am allowed to make that joke without any repercussions. So then let me move on here. There's binary classification. There's multi-classification. So rather than a 0 or 1, you're going to have 0 to n classes. Technically speaking, it's 0 to n minus 1 classes. And then we have standard linear regression. Now, linear means we're going to make a prediction based on a linear function of the input features. Now, what I hope to do today, like as I said, is cover some binary classification, because once you've seen binary classification, multi-classification is just a pretty quick step up, and linear regression is the same. So I have pre-populated a little bit of this notebook. I don't want to sit here and type it all. Nobody wants to see that. And also, here's a great icebreaker for you. If you want to put into the chat window, so it's recorded for history, I'm taking a poll, an over/under. How many times is Chris going to hit backspace in the next hour? And that's Chris Burns. It's not Chris Skrinek. I heard he types like 200 words a minute flawlessly. So like I said, we're going to get started here with the classification algorithm. Now, the way you choose, remember, SageMaker is based on container images. So when we decided we want to use the linear learner, we're going to select the linear learner image from our collection in the ECR repository. The only difference you have to specify here is when we create the hyperparameters. We're going to have a predictor type. We'll see this in a little bit. So if you're wondering, from the start, we use the same image for all three, whether it's binary, multi, or linear regression. And we actually use the same image for hosting as well as training. We'll see that here in a moment also. So I wanted to take just a couple minutes. I do apologize, but I feel it's necessary to get us a grounding here in linear regression. Linear regression, it's quite simple. It's a simple equation. So if you give it a set of points, and I chose beta there because that's what I remember from one of my classes is partial slope coefficients, and we are just calculating the slope, the rise and the run of a slope, which we'll see in a moment. It's quite a simple algorithm. And then if you see the hat, the little carrot shaped character, that's representing a prediction. I'm not going to go into too much math, but I did want to put that right there for you because I want to go over the data set very slowly. I'm going to put the data set together. I put it together ahead of time, but we're going to analyze the data set slowly so that you can see that live. If you've been to any of my other webinars or my workshops, I really stress the data set. I don't really care for demos and training and tutorials where they just give you a polished data set without telling you how it was put together or how they got to that point in time for their feature selection. So if you're new to Python, this is all written in Python. I'm going to go somewhat quickly, so don't think you have to learn Python right here on the spot, but I do want to at least speak to each line of code that I write today. So if you're new to Python, the import statement really just means I want to borrow code from this particular library. NumPy, Matplotlib, Pandas, we're going to go over all these in a little bit more detail in a little bit. So I'm just setting up my code here. Now, from SageMaker, we have the SageMaker SDK here. We have a built-in function called getExecutionRole. I'm going to set this variable called role to the execution role. And what that's going to do is going to capture who I am. So when I logged into SageMaker with my credentials and spun up this notebook instance, it knows who I am. It's captured that in the role. So now I can provision resources when I go to do the training and when I go to do the hosting. So that's all taken care of for me. Obviously, S3 is the substrate for anything you do in terms of data. So I have a bucket out there all ready to go. And it also has a subfolder with a prefix here called housing. So I want to get back to regression here. Given these simple points, I want to just demonstrate what we mean by regression. And before I get into that, I want to make a note that linear regression is never actually perfectly linear. So you're going to see a lot of straight lines. I understand that it's never exactly that way. This is kind of a 101. Get your feet wet with regression and see what the linear learner built-in can do. So given these points, as a matter of fact, I didn't even put a label. I apologize, I'm taking a drink. I didn't even put a label because I don't want you to worry about what the data is. Another thing I stress in my workshops and my presentations is I get questions all the time. What's a use case for this vertical, or what's a use case for this industry? And that's really the wrong question to ask. Data is data. Data doesn't care if these X and Y points are age and blood pressure, if it's RPM and temperature, if it's dark matter concentration and kryptonite. It doesn't matter what it is. What we want to do is we want to find out if there's a correlation with that data, and we want to plot the line of best fit amongst our points, which leads me to my next item here, this line of best fit. Now again, this is our perfect imaginary world. This line that we've drawn here crosses through all these points perfectly. There are the same number of points above the line as there are below the line, and that distance from the line is what's called our error. We're going to get into that in just a little bit, our squared loss metric. And we want this line of fit here to go perfectly through that. So what I've done here is I've rewritten I've rewritten these points. These are the same points that were here. I've written here, and I'm going to put them into a scatter plot. So we got my points. Now, if you're new to Python, if you know another language before you knew Python, then you might be the same boat as I am. But Python slicing and splicing is very bizarre. Whenever you see this bracket, we're working with an array. And so what I'm saying here is that I want all rows, but just the first column as my X coordinate on my plot. And then my points. I didn't hit backspace, so it didn't count. I used the arrow key. All rows, first column for the X coordinates. And then it's a simple plot that show. Now I'm using here this plot. Here's my first backspace. Plot is my matplotlib. Again, if you're new to Python, new to Jupyter Notebooks, it's a visualizations library that you're going to use quite frequently. And so if we run this cell, I get an error already. My apologies. I told you about this cell, but I did not run this cell. Okay, so now I've imported all of my libraries. And you see here that I've just scattered these points across the chart. Now, again, this is going to be fictitious. As a matter of fact, I'm going to just copy and paste this because there's not a lot of value in me writing this out. But if we were to have our actual regression algorithm run, we would want to see a line similar to this. So we got the same number of points above and below the line, and our distance is about the same from the line. So we're going to have a pretty standard deviation. Now, again, this is what earlier I talked about. This is what attracted me to linear regression first, is because this is math that I could understand. This regression is really just a slope. It's the delta of y with the delta of x. So it's basically a rise over run problem. This is math that we might have learned in high school or first year of college. So this line of best fit is really synonymous with rise over run, and that's what started to make it click for me. So that's all I want to talk about with regression. This is the basic theorem that's going to be underlying all three of these versions of the model, the multi-classifier, the binary classifier, as well as the linear regression. So now I want to get into the data prep here. Now I have selected a data set. I've pre-built it, but I'm going to go over it in some detail. And the scenario I'm going to put out there for you, I found it's easier to just put a scenario. We're going to say that I'm a very wealthy real estate mogul, and I have the inside track to where HQ2 is going to go. That is not true. That is just the scenario. So I don't want anybody leaving this webinar and saying Chris Burns said he knows where HQ2 is gone. And so what I want to do is I want to set up a system for my my employees to automatically get permission to purchase a property. And so what we're going to do is we're going to put an algorithm together that's going to take a lot of a lot of features of the properties, and if it's below a certain, if we expect it to be a threshold of like worth $22,000, just go ahead and buy it, because I'm so confident that it's going to rise. I'm going to just make money. So right now, my housing file is sitting on S3. So I'm going to go to the Botto3 framework here. Now, Botto3 is it's the old school AWS SDK. All of our services and features that have software interfaces and APIs are wrapped into Botto3. So what I'm doing here is I'm going to establish a context in an S3. So I've established a Botto3 library with a focus on S3. Now, key, you're going to see that very often in AWS S3 land. Key is usually the name of the file that we're talking about. And this is probably not the best way to do this. You could use os.join would probably be the more cleaner way to do this. But I'm setting my key equal to the prefix that I have already established up top plus the name of my file. And then I'm going to download that. So it's s3.bucket bucket name .download file. And the more you use this, the more you will memorize these commands. HousingBoston.csv. So that's going to download it. That's going to download it to the drive, to the notebook instance drive. I put these comments here out of place, so I'll move these. So when I distribute this notebook at the end, this makes a little bit more sense to you. All right, so we got that file. It's sitting on our local hard drive. Now we're going to introduce you to pandas. NumPy, pandas, and MATLAB are probably the top 3 libraries you're going to use when you're preparing your data sets. NumPy is a library for advanced mathematical equations as well as advanced work with matrices and arrays. Now pandas is it's great for easy to use data structures and data analysis tools. So lots of value in pandas, lots of value in NumPy. There's some overlap there, but they're two. I'd say 2 peas in a pod. Now, I like to use the variable data. Some people like to use something that's a little bit more descriptive, but I'm going to read this file that I just downloaded. I'm going to read it into a data frame. This is PD, this is pandas, and read CSV. This data format is going to be a data frame. In Python, if you're ever curious to know what's going on with an object, you just do data. Shape, and it's going to tell you I got 505 rows and 14 columns. So that jives with what I believe I uploaded. Now, this line of code, I had it here sitting. I didn't, no value in me typing this. These are the, this is actually, prepare. This is the median value. This is what we're going to train against. And it goes first. So when you're using the Amazon built-in, the linear learner built-in, excuse me, you could take CSV files or you could take record IO wrapped protobufs. We're going to use record IO wrapped. That's the preferred one. You can use pipe mode rather than just file mode when you're using that. So you get optimized file data transfer from S3 to the notebook instance. But a couple of things here is the target column should always be first. That's just a standard practice here at with the SageMaker built-ins. And then you should not have headers. So I'm going to add these headers separately. All right, so that ran. A handy command with pandas is data.head. What this is going to do is going to show me the top five rows in my columns. So that's looking good there. And also, what I should do is display. Display is a built-in excuse me, function of pandas that basically does a pretty print here. You see the difference between these two. So if you're working with a client or partner or somebody that you're trying to help out, this is much easier to read here. So I recommend that. And then we want to get into the actual data here. So what I want to do is use one more built-in pandas command. Let's call it describe. So now what I get here is I'm going to get some interesting facts about my data set. I'm going to get the mean, I'm going to get the standard deviation, the minimum, and my quantiles. So this is a great way of taking a look at your data, making sure that you don't have too many outliers or that your standard deviation is too far off. You don't want to train on that if it's out there, if it's just crazy. What you're going to have to do then is you're going to have to move into what's called a scoping exercise, where you take the values and you scope them down to a much more narrow range. All right, so then the other thing I love to do, well, I don't love to do it, you almost have to do it, is take a look at the correlation. So the describe does a great job of showing us these cookie cutter features. But if I do a data.correlation here, core is the correlation. The default is a Pearson. And if anybody can't, I know that as soon as I hit, when I run the cell, it automatically moves my screen. So if it's moving too fast, somebody please let me know. And so this is giving me my correlation. Now, obviously, because I did not exclude this median value, that correlation is going to be 1,000. It's going to be 100%. So what you can also do here, see if I can remember this syntax, is you format this. And let's see, it's .2. This is just a padding, spacing if you will. And what I'm going to do is I'm going to go get a background gradient from matplotlib and show basically what's called a heat map. CMap's a color map. Plot.get CMap. Cool warm, I believe, is the default. So this is much better. So now what we see here is the dark red is a very high positive correlation, and the dark blue is a very high negative correlation. We don't care for this example if it's really high or positive or negative, as long as there's a definitive correlation there. When you see these very light colored and these gray squares, the correlation is very low. So you may have a hard time getting a good regression out of this. So what I'm going to move into training now. Now I've got I'm going to skip over this because I'm running a little bit behind schedule already. This is, you choose what metric you want to train against. You have objective loss, which is the mean value. That's the great for binary classification and linear regression. But you also have just accuracy. You have your F1 score, you have precision and recall, which all tie back into the confusion matrix. And if you're new to machine learning or relatively new, this is a topic you're going to see a lot. It's really, I'm going to tie it all together here at the end of the webinar. It's something you should definitely know, but I'm not going to go over it right now, as I said. But you're going to get this notebook afterwards. So if you want to go over that, that's highly recommended that you do. Okay, so I have my data set. I've taken a look at my data set. Now the exercise that I just did was obviously already done. So I didn't find any problems. I didn't have to change anything because I did that before we got on the webinar today. But that's an exercise that you should certainly become proficient in if you want to do machine learning on a regular basis. So what I'm going to do now is I got to split my data set. We all know that we want training, we want validation, we want testing. I recommend the validation. The linear learner, they prefer that you test against validation rather than training. I haven't really seen a difference with this example, so I'll probably just stick with the training. But we want to split this up. A couple ways to do this. There's no set way in stone. What I'm going to do is I'm going to use NumPys again here, and I'm going to create an empty array, the length of my data set. And then what I'm going to do is I'm going to create a list from the training set. Of anything below 0.8. This is a poor man's way of saying 80%. I want 80% of my items to go into the training list, and now I've obviously set this up beforehand. I'm going to do the exact same thing for validation and the exact same thing for test. So validation is going to be 15%. That's from 0.8 to 0.95, and then test is going to be anything above 0.95. Now that's my list. That's not actually my data yet. I don't have my data in separate arrays yet. So I'm going to create that now. And I'm going to feed that list into a fresh array and copy it over so that I'm going to have 3 arrays for training, for validation, and for test. And if we want to take a quick look at data train. All right, looks good. So this guy here is breaking it out for me. It's too wide to fit. Okay, so now that that's done, what I need to do is get these. I need to get them suitable for the labeling and the training data. So what I have here is I have 3 arrays. One with 80% of my data, one with 15% of data, one with 5% of my data. But this is not ready to be trained on, because in training I need to know what the label is, what I'm training against, basically, and then I need to know what my other features are. So we're going to do that now. And I don't know where it got started, but it got started somewhere. That Y is usually your label. And what we're going to do is we're going to use another function of the pandas library called iloc. Basically, it's a location is what I've come to know it as. And what it's going to do is going to allow me to select certain columns of my array and move them to another one. And so what I'm saying here is I want to use all rows in the first column. But this is probably the most important line of this entire notebook right here. Is we're determining what we're going to train against, what's our feature. And what we want to do is we want to say, okay, any property that we think is going to be valued at over $22,000, buy it. So what I want to know is if I'm going to predict that the value is going to be over 22, then to buy it, because this first column here, this median value, is the monetary value of the property. Now, if you recall, because we're doing binary classification, I said you have to really ask it a yes or no question. You want to return a 0 to 1 scoring. So what we have to do is we can't leave this array. I'm sorry, this spectrum of prices in here. We need to convert that to either yes or no. So what we're going to say is we're going to say if it's over 22, well, then we're going to make it a yes. If it's not, we're going to make it a no. And I've forgotten a parenthesis here. And then finally, this is a little bit old school, as matrix. It might even be deprecated by now from Pandas. I think they use values a lot, but I'm going to spit this out as a matrix. So what this is going to give me is going to give me my labels, just the first column, and I'm going to convert anything that's 22 or over to yes and no, 0 and 1. I'm going to do the same thing now with my features. So same syntax. I'm using the iLock library from Pandas, all rows. But here, what I'm doing is I'm starting with column 1 and everything else afterwards. So that's what that 1 semicolon means. And if I want to check, see what the shape there is. All right, I got 403. So that sounds about 80%. And I have 13 features, which is correct. We start with 14. I obviously took out the target, and we are ready to go. So next step is we're going to get this uploaded to our channels. SageMaker is always looking for channels. I didn't need to add that. Sorry. So we're going to create a file called training file, and we're going to well, this is the variable. It's going to be called linear train data, and we want to convert this to the record IO. So this is actually relatively simple. F is basically the universal symbol for bytes, and we're going to create an array of bytes. This is an in-memory byte array, and what we're going to do is we're going to use the SageMaker Commons. I call it SMAC, but it's the SageMaker Commons library, and it gives us some functions to use. This one's called write NumPy to dense tensor. I'm going to supply it the buffer that I'm going to write to. What data do I want to write? I want to write my training data, but I want to make sure I specify that it's as type float 32. And then I also want to include my labels, which are in a separate array at the moment. Also, float 32. Now, when you're working with in-memory byte arrays and you write to them, they increment 1. And for every byte you give it, it writes to it, and it persists that. So what we want to do is we want to reset that back to 0. So when that's used again, that's a good habit to get into. And then we're going to upload that to S3. Now you see here I've created a subdirectory called train, because SageMaker training, they want to see something in train, they want to see something in validation. We're going to see that in just a couple of more cells. We'll run this. Now I'm going to repeat that process very quickly for the validation set. Validation, looks good. Well, doesn't look good. Because I didn't repeat the process up here. So I made my training features and labels, but I did not do it for my validation or my testing. So all the same. Pulling from data value array to data test. Okay, so that's good. I'm happy with that. Don't need to rerun this, but I do need to rerun this. All right, so we're back on track. Now, we're ready to train. We got to get a reference to the linear learner image. And so we're going to use the SageMaker API again. And that's SageMaker Amazon estimator. All regression models are basically called estimators. And we're going to get the image URI. So what happens behind the scenes in this function right here, get image URI, is you're not going to see any repo addresses or anything like that. All you do is pass in a string for the container that you want. We're going to call our variable container get image URI, and we're going to refer to our Botto 3 session. If you recall, the session we started in Botto 3 above is going to have information about our region, about who we are. This is a good practice to get into so that if you pass this notebook off to somebody else, you didn't hard code a particular region that you were in, it is going to follow them wherever they go. And we want to be certain that we grab the linear learner. Image. All right, so we have our container images. Now, this one I've already left here, but like I said, we're going to walk through this. This is really just a JSON file. It's nothing more than JSON that's going to pass in the parameters that our training environment is going to use. So we've given it a name here, basically the deep dive linear, and then we've added formatting so that we can run this every couple of minutes. We can run this from a, I want you to think for a second here about your code. When you're writing code, you always want to look at your code from the perspective of it's in production. So you don't want to get into the habit of thinking that you're going to come back into this console every time something needs to be launched or initiated. You want to write your code as if we're already in production. So get used to using variables such as this. This is going to let you spin up, reuse this code every couple of seconds, even every 1 second, and it's going to give you a different job name. Job names have to be unique. So again, I'll step through this. We've already established what our container is, our container image. We've pointed it to this method, which returned that for us. We're going to use the file input method here. We're not going to use pipe mode because it's so small. We won't see any differences in performance here. I want to train on the C42XL. I don't need GPUs for this. This is this stochastic gradient descent with a relatively small data set. And I just need a modest volume and gig. Now, this is important. Input data configurations. This is where the channel for validation and training are going to be mapped. So if you'll recall, we created in our S3 bucket a training subdirectory. Well, I did it beforehand, obviously, but you saw a reference to it. So this is where we're telling SageMaker, my training data is in this channel, my validation is in this channel. And we're going to specify where our completed model is going to go. And then finally, our hyperparameters. So the one thing I want to draw your attention to here, the linear learner, what it does is basically you have a choice of optimizers, you have a choice of several other hyperparameters. The linear learner will do up to 32 models at once for you. I'm not going to kick this training off. I've already trained this exact same configuration prior, so we're going to jump to the logs in just a moment. But what I'm going to do is I'm going to get 32 different versions of training, and it's going to give me the best option back. So it's sort of, I don't want to call it built-in hyperparameter optimization, although it is. You could still use our hyperparameter optimization to get very, very fine-tuned. I suggest the larger data sets for that. Small data sets such as this, you're probably not going to find a lot of difference. But I'm going to run this cell so that this JSON is all stored up. Now, that's where I'm going to quit with this part of the notebook. This next cell, I'm going to show you what it is, but I'm not going to run it because, like I said, this is going to kick off a training job. It takes about 6 minutes. What I'm going to do is I'm going to cut to some training that's already complete, just like a baking show, so that we can see what happened there. So again, I'm going to get a reference from the Botto. This is a Botto client, so I want you to note the difference there. Before we borrowed information from the Botto session, here we're getting a context back, and this is the SageMaker context, and we're going to call it SM. And what it's going to do is going to give us a library of all the functions, all the library calls within SageMaker. And we're going to create the training job from that library. This 2 asterisks here, this was new to me when I moved to Python. What this is doing is this takes many, many parameters. Some are optional, some are required. When I give it the double asterisk and then this variable name, it's passing this entire JSON in to satisfy all the parameters. And what you need to do is make sure that your JSON is very clean and you have no misspellings. So it can match those, it can map those to the parameters. Now here we're going to declare a variable for status. And this call to describe training job is actually what we're going to use this repeatedly. You'll probably use this a lot. Again, I was talking about your code from the perspective of production. you're not going to come out to a notebook when you're in production. You're going to have this running from somewhere else. It could be a Lambda function. It could be some other business process. So this is code you should be using in your production processes to see the status of your training job. And then this one adds a waiter. Obviously, this is not relevant to us at the moment. This waiter is just going to sit here and wait and wait and wait until we either get a failure or a complete. Again, now once that training is done, we're going to add a model. It's going to be deposited on S3, and we're going to set up the same process again for the hosting. Now, again, I'm not going to step through this, just go quickly, and we'll get into the actual inference here in just a minute. This is going to create the model context. So when you have a file, even if it is a model that the training process is deposited on S3, SageMaker doesn't know that's a model. It's just an object sitting there. You have to give it context, and you give it context by creating this model, this create model called a SageMaker. And here we're going to it would print out the ARN for the model. Again, we don't need that. And finally, the endpoint configuration. If you've done anything on AWS, if you've done something like auto scaling, you create an auto scaling configuration file, and then you put that into practice whenever you need it. It's the same thing with endpoints. You have endpoint configurations, and you have endpoints. The configuration can be put into production over and over again without rewriting. So we delineate between those two. What we're doing here is I want to run my inference on an M4 XL. I only need one. I'm pointing at the model that I want to run, and then I'm telling it all traffic. We can do A/B testing here, a couple of different options for multiple models behind a single endpoint. And then the next cell is going to deploy that, actually deploy resources. So when you're using this, be careful. I did not put any code in here to delete these resources, so be mindful if you run this afterwards that you go back and clean up after yourself. So here's where we're going to pick up again. This is a little helper function to convert back to CSV. We want to pass CSV to our inference rather than a record IO. And so this little function does nothing but convert back to a CSV file, and then it also saved it to the hard drive of the notebook instance, which I'll show you in just a moment when we do our inference. And this needs to be changed because I have an endpoint running. What I've done is I've hopped over to the SageMaker dashboard here so that I can grab this. So this notebook's going to pick up on an endpoint I've already deployed. All right, and then if we go to, here's my test observation CSV. And what I did was I took a copy of all the test observations and dumped them into a CSV file so that we can map them here in just a few minutes. And then finally, it comes to the point of inference, because this model has already been deployed in a previous run of this notebook. I'm going to send, actually it's already sent, so sorry, I lost track of where I was at. So let's see what we have in this test predictions here. Look at it in raw form. Okay, so those are our scores. That doesn't really tell us a whole lot. So we can look at this in a couple of different ways. Let's print the entire result first so you can see that this JSON. This is the JSON that came back, and I got a scoring for each item, each observation that I passed in this CSV file up here. Now, let's go back to the beginning here. Binary classification is from 0 to 1. So what I'm saying is that if my score is above 5, then that means I believe something to be true. So in this instance, I'm predicting that if my score is above 5, then that particular property is a value greater than 22,000. If it's below 5, then the value should be less than 22,000. And this is just a quick math to see how we did. So 86.7%, not great, but for just a quick demo that we threw together like this and without going back, oh, I completely forgot, I apologize. I wanted to go to the CloudWatch logs. So let's pause there for 1 second. We're going to go to the logs, my training job logs. We're going to find the training job. I should have cleaned that up beforehand. I do apologize. Let's look at this one. No, that's not it. I do apologize. Please bear with me for 1 minute. Actually, I think any one of these will show as long as it didn't fail. No, that one failed. Okay, so this is a log file that SageMaker writes. You don't need to do anything to set this up. This all happens behind the scenes for you. It's incredibly important. So if you've done any kind of machine learning on your own in Python, we love to write those print commands in the for loops within the code itself. We don't get to do that with SageMaker because the training is all handled from that pre-built image, the built-in image. So it does all this logging for you. And what I want to draw your attention to here is this. If we look at this first, this is model number 0. And what it's doing is it's doing our absolute loss because we said we want to train against absolute loss. This was our MSE, our mean squared error loss. And then what it does is going to do that. There's 32 entries here. So if we come onto this guy, 0 to 31 equals 32. And then what it's going to do is SageMaker is going to say, okay, I ran all 32 iterations of the possible model between the optimizers and the hyperparameters. And did my loss improve? So we see here, after epoch 0, loss improved, updated the model, and then it moves on to the next epoch. Epoch, epoch, I always coupon, I go back and forth on that. So that way I can have plausible deniability if somebody says I said it wrong. So no need to step through these logs any further than this. We had 10 epochs of 32 different models running, and what it's going to do is going to choose the best model for us. So there's a lot of value there. A lot of frees you from the the tedious details of training that, because it's all going to come down to what your success criteria is. What are you training against for your metric? Is it absolute loss, or are you going to go for precision? Or are you going to go for something else? And then like I said, it just frees you from that tedium. So I'm going to come back here to our score. Now what I've done here, again, this is, think of this like a baking show. I've done some of this beforehand because we only have an hour, is I've built this quick spreadsheet. Hopefully this, I didn't move that in there too fast. And what I did here is these were our test observations. So I've added back the median value. This is that call to iLock in pandas is what it changed it to. So I wanted to actually verify that if it was below 22, it was changed to a 0, and if it was above 22, it was changed to a 1. And then this is a score that we got back from our inference point. And what I've got here is I've got 23 predictions. I like to use 5% for my test. I like to do more training and validation than a lot of testing. And 6 were incorrect. Now, for this instance, going back to the confusion matrix, do you want to train for precision, or do you want to train for recall, or do you want to train for F1 score? In this particular, if my fictitious scenario were true, I would have missed out on 5 buying opportunities, which is not great, but it's better than buying 6 properties that did not meet the criteria. And so in this instance, we had 1 false positive. So I would have purchased 1 undervalued house. And so that's really what I wanted to go through today for this binary classifier. I wanted you to see the code. I wanted you to see, how the training resources and the endpoints were deployed. Let me hop back into the SageMaker dashboard just to make sure that you see the endpoint configuration. I didn't clean this up very, very nicely, but the endpoints here. So this is the endpoint that's running. It's important when you're doing testing to come back in here and delete. Matter of fact, you should write some code in your notebook that deletes this, either on a either run the cell yourself or build a Lambda function to come out here and do some cleanup work. I do want to impress that upon you. I've left these running quite a bit myself, and very, very irresponsible. And when it's an AWS employee, it's irresponsible, but when it's one of you, it's money. So I wanted to leave that out there. So that's the presentation. I'm going to share this notebook with everybody that joined the call today. Hopefully it recaps all the information I delivered today. My email address, I will put that in this notebook so that you have that if you want to reach out to me with any questions that you might have. And then with that, I guess, Chris, we can go to the question. Looks like we got 12 minutes left, so we can go to any questions that might be out here.
Yeah, there's nothing in the queue here, so let's open it up. If folks have questions about the presentation. Now's the time.
So either one of two things are going on here. We have linear regression experts on the call, or I did such an outstanding job explaining it, nobody has any questions. So one of those two things have to be true, right?
Well, I will make a comment that I like the way you went through the pandas breakout. I think that's an essential aspect, especially for developers now coming to machine learning for the very first time.
Yeah, it's important. The data sets are where your accuracy is determined. Your accuracy, your model can't determine an accuracy over a bad data set. I'm sorry, it can't achieve great accuracy over a bad data set. So it's important that if you're a developer, if you're a data scientist, you've already been trained in the area of statistics. But if you're a developer like I came to machine learning, I had literally zero statistical knowledge. And I started playing with R a lot just to get my head around statistics. And then when I found the pandas library in Python, it was fantastic. But as you pointed out, Chris, it's I can't point that out enough. Like these, for instance, we'll revisit this, the standard deviation. Some of these are pretty, like this guy right here, 168. You have to take into account what we're talking about here to see. Now this is tax, so that's a pretty wide deviation. And if I want to get this model more accurate, what I could do is I can scope that. And so I take value. I should probably have set up a scoping exercise, but I did not, so I apologize for that. And then the correlation, of course, is if you run this correlation and you use a color map like this and you have no dark blues and no dark reds, you're going to have a hard time getting any kind of accuracy on your training, because there has to be relationships in that data in order to come to the same conclusion. So,
Chris, there's a few compliments here, which is great in the questions, but there is something here that says, for what kind of use case would we use linear regression?
Well, linear regression, you'd use that with, again, I have a background in mechanical engineering, so my train of thought always goes to the manufacturing world first. So let's say you have a preventative maintenance plan that you want to put in place, and you've been taking data from sensors on machines, we'll just say they're presses, just a generic press type, and you want to know at what point in time is this going to break down. So there's really two questions you can answer there. You could say, is this going to break down today, which is a bad question to ask, or you can say, do I have a guess as to how many days I have until this breaks down, which is a much better a question, and you would use linear regression for that because it's going to be a linear value. So when you run that equation, you could run it once. I'm sorry, when you run that training or inference, boy, I apologize. When you've trained a linear regression model and you run inference across that, because it's linear, it's going to tell you based on the data, this is going to break down in 1 day. Think of it as a time to live even for the machine, or it's going to say 45 days, 60 days. And what that does is it's going to narrow the scope down for you so that you can have your maintenance men do preventative maintenance on any machine that comes back that's predicted to break down within the next 30 days. So I wanted to draw a delineation here between a binary classifier and the linear regression. The binary classifier, you're going to be asking, is the machine going to break today? And you don't want to ask that question, because if the answer is yes, you're already too late. You probably can't shut it down gracefully and get your people out there to do the maintenance or order the parts. Linear regression, you're going to get that window, that sliding scale.
Well, if you don't mind, Chris, I'll just add a little color to that. I like to say that all prediction is using the data you have to create data you don't have. And in the case of a linear regressor, you're typically predicting a number. Do you want to talk about the difference between logistic and linear regression?
I thought about that, and I did not want to on this call, because if we, I don't want to muddy the waters between logistic regression and linear regression.
No worries. We're going to be covering that in later webinars, so please stay in touch with the series. There's another question.
I will just throw out, with logistic regression, you're talking about a discrete response, a discrete answer. With linear regression, you're talking about something that's variable. It's a sliding scale. That's why I like to use those dates. It could be 1 day, it could be 45 days. Whereas logistic regression, you're looking for a discrete value there.
So there's another question here, Chris. Is there an optimal number for the num models in your hyperparameters, and what would you suggest we start with?
32 is the max, and I suggest you start with 32 because it does not appear to add much resource consumption at all. So there's no sense in saying I want to just do 5 or 10. If your data set is under 10 gig, just do all 32, and then obviously set your training environment accordingly to the data. But that's my recommendation here. It's a really cheap, it's a really inexpensive way to get some hyperparameter optimization done for you for free.
And we have a few more that are just bubbling up here. What tools do you like to use to clean up the initial data set for analysis? And what the specific reference here is, how do we take care of blank data entries, formatting, etc.?
Yeah, there's a lot of opinions on this, and I use a combination of text editors, of databases. It really depends on the data and how I want to visualize it. It's not easy to just put everything into a pandas data frame and start hacking on it that way. But sometimes I spent a lot of time with SQL, so sometimes I'll actually import CSV files into a relational database so I can start doing some select statements to filter it out for me. Obviously, that's not always possible. So unfortunately, I'm giving you a very political answer of it depends on the data type. But when it comes to the missing values, I am pretty brutal with missing values, and I dismiss them. I eliminate that observation. A lot of people will take the mean of the column that's missing and add that, and they claim it's the same thing. I don't like that because I'm adding data that's not actually generated by the originating mechanism, and so I eliminate those. Now, obviously, you're going to get in scenarios where you can't do that because you just don't have enough data to train on, which then you would take the mean of the column of the value that's missing and input it in there.
I'm also getting the links here. I also want to recommend to the team that you check out Trifacta and Praxata, who are APN partners that specialize in that. I'm getting the URLs right now. Can linear regression be used for trend forecasting?
Well, trend forecasting is usually going to be linked to a time series database, and I would probably go more with a deep AR. Linear regression is very flexible. It's really, I didn't want to do this webinar at first, but then I realized, I'm kind of dismissing linear regression because it's not the new hotness, and really this should be a commodity to everybody. So the answer to that question is I think there's better algorithms out there, but you can always try it because it's so easy to try. It's so inexpensive to try. But my guess is that your results are going to be less accurate than like a deep AR based algorithm. But just to finish that comment on linear regression, when I was a developer many years ago, I used to write my own log classes, and I would add it to my own code. And then Microsoft came out with these enterprise blocks, they called them, and it was like a logging block. They commoditized logging. Linear regression should be commoditized in your portfolio of skills and services, because today I've seen a lot of services that are business processes that are based on like a single inference point. I mean, maybe a single SageMaker inference point. What we're going to see here in the very near future is you're going to see business processes that are based on multiple endpoints, multiple inferences, multiple. So linear regression really needs to become a commodity, because you're going to be using that a lot. You're going to use these to inform maybe deep learning models. You're going to use these to inform reinforcement learning models. So it's really got to become a staple for everybody that wants to be a machine learning practitioner.
There's a question here regarding scale. The question is, what if your data is too big?
Yeah, well, I would love to hear about a use case where your data is too big. I know when our built-ins were announced, we took great pride in demonstrating, especially some of the naive Bayes trees. When we say that SageMaker is built for infinite scalability, we're not mincing words. It's not lip service. I would love to see a data set that you think is too big for stochastic gradient descent, and then if it is, we can work with the service team to see what we can do to make that not an issue. And also, when your data set is very large, you definitely want to look at the pipe mode, because what the pipe mode does is basically takes one pass across the data. And I can't speak to the inner workings of it, partly because I don't understand it in its entirety, and partly because we're not allowed to know about that because it's kind of some secret sauce. But with pipe mode, you're going to get better performance on very, very large data sets because the data is handled in a different manner. So that's what I'd say to that.
Chris, I think we have just time for one more here. Do you mind going to the SageMaker console and showing us the GUI approach to launching the linear learner? The question here is, could you go over the use of hyperparameters in a little bit more detail? And the reason I asked you to do that is they're all pretty explicitly given when you use the GUI.
Yep. So I'm in my training jobs section of the dashboard, and this was the JSON file that was rather lengthy, had the input, the channels for input and for training and validation, and then we see here my hyperparameters. Now some of these I can't change. Obviously 13 was how many features I had. I can't change that. This one I can change. I went for absolute loss. There was a couple of options that you can put in here. Your batch size, you can change that. This is the number of consecutive or the number of parallel models that you're training against. So it's 32, which is the max. And then again, here's the predictor type where I chose regressor, and you could choose in here.
And Chris, do you mind clicking on Create Training Job and choosing the linear learner? Just to, create training job, and then choose linear learner from the algorithm pull down. Next one. Here we go. And then scroll down, and you can see the hyperparameters down below are explicitly given, some of them as actual pull downs.
Yep. So my final thought on that was going to be, if you consult the developer guide in SageMaker, it will give you the complete list of these features. And so here, do you want to target recall? Do you want to target precision? This is going back to the confusion matrix. Excuse me. And what do you want to train against? And then your loss quantiles, margins. You could do WD and L1. We don't have L2 just yet. I'm not sure why. That's the ridge regression, but we do have WD and L1. And these are actually taken care of for you in those permutations of the model, the 32 different parallel runs. And then you'll have these should be atypical here, these learning rates. So what was the original question again, Chris? I want to make sure I answered that properly.
No, I think you did. It was just a bit more detail on the hyperparameters themselves. We're at the top of the bottom of the session, halfway through. So I think this is all the time we have without going over. So Chris, thank you very, very much. It was an enlightening session, and I loved the 100% notebook approach.
Oh, thanks, Chris. And again, once again, we'll pass this notebook out. There's a quick survey that we're going to email to you. Please fill it out. It helps us become more efficient and more effective at what we do here to deliver these webinars to you. And then again, any questions, hopefully by now, everybody has my email address. If not, it'll be with this notebook, and I'm here to help you out. So thank you again for your time.
Thanks, everybody. Have a great day. You're going to get an email about 6 hours from now with the video file from this call, so you can go through it. That email will also contain the registration link for our next webinar, which is going to be Chris Skrinak presenting. So register for that. We'll see you in 2 weeks, and hope you have a great rest of your day.